Today we're going to look at exponential and logarithmic equations. We've talked about how if we have log of something without the base written, we assume that the base is 10. We can also have any base for that log. Another commonly used base for logs is e. E, remember, is an irrational number just like pi. And if you didn't watch the extension video last unit, e is, if you go to your calculator, use this button here. If you do that to the power of 1, your calculator gives you a rounded value of e. It's about 2.718. But just like pi, it's this decimal that never ends, it never repeats, so it's an irrational number. We can't write it as a fraction. It has many other interesting properties that you'll later discover in calculus. And to write the log of base e, instead of writing this, so log base e, we actually just write, so if we want log base e of 3, we write ln, which means the natural log of 3. And there's no base written, but it is the base of e. So it means log of base e, but we don't write it that way, okay? If we're given this logarithmic equation, we can write it in exponential form. So our base is e, our exponent is y, and x goes on the other side of that equal sign of the exponential equation. So some properties that you should be familiar with. Ln of 1 is 0. That's because if we were to write this in exponential form, our base here is really e. So e to what power we're thinking is equal to 1. And of course, e to the power of 0 is equal to 1. And actually log base anything, whether it's e or 10 or any number of 1 is going to equal 0. If you think about it, log base 10 of 1, in our heads we're thinking 10 to what power gives me 1? Well, of course, that's going to be 0 too. 10 to the power of 0 is equal to 1. So x equals 0, which means log of 1 equals 0. We could do the same thing with log base 3. Okay, and in our heads, we're thinking 3 to what power gives me 1? Again, it's going to be 0. 3 to the power of 0 is 1. So this, any log base anything of 1 is going to be equal to 0. Remember, log of 0 does not exist. We talked about that in the last video. It's not part of the domain. There's nothing that 10, if we're dealing with a base of 10 here, 10 to no power is ever going to give us 0. So this does not exist. So remember, our domain for logs, the base for sure has to be positive, so this number has to be positive, and this number has to be positive, which means greater than 0. Ln of e is 1. So if we were to write that in exponential form, we're using the base of e here, which we don't write, so e to the power of 1 is equal to e. That's what that's saying. This is our base, our exponent, and that's this e over here. Ln of e to the x is x. Anytime you have the same base, remember we looked at, like, if we have log base 3 of 3 to the x, we said we can cancel this part and we just get whatever that exponent is. Same thing here. We can cancel ln and e, and we're just left with our exponent. Just some things that you should be aware of. I didn't write these in your booklet because I don't want you to remember them because they're not actually true. So some misconceptions. So log of a plus b, we cannot distribute log. So it's not possible to multiply log, for example, in like that. Not possible at all. These are not the same thing. So log of a plus b is not equal to the log of a plus the log of b. Remember, the property that is equal to it is this one. The log of a plus b is equal to the log of a times b. Okay. Same here with this second idea. We cannot distribute log over a minus b. Log of a minus b is equal to this one. Log of a divided by b. Okay, so those are the things that you need to remember. Do not distribute log. It doesn't work like that. It's not multiplication, it's a function, and it works in a very specific way. You can't distribute log, okay, ever. So log of a plus b, remember, is equal to log of a times b. Okay, so it changes to multiplication. Log of a minus log of b is equal to log of a divided by b. Okay, also realize that log of a divided by b, so this one, is not equal to this one over here. Okay, they're totally different things, and we're going to look at that more today. Okay, so we have addition between the 7 and the 4, so that's going to turn into multiplication. And we have subtraction with the 2, so that 2 is going to be in the denominator. So any term that's negative is going to go in your denominator when you're combining your logarithms. So these all have a base of 10, which we just don't write, and we're left with log of 28 over 2, which is log base 10 of 14. Ln of e squared. Remember I said these can directly cancel, so it's equal to 2. But let's look at why that is. So it's totally okay to just use that shortcut, but it's also important that you understand why that shortcut works. So for now, let's say this is equal to e. Okay, so ln, remember, has a base of e. So if we write this in exponential form, we have e to the power of x is equal to this e squared. So then, of course, x equals 2. X is what this whole thing is equal to, so the whole thing is equal to 2. We can't cancel the ln and the e until it's all one logarithm. So let's just focus on this part right now. Okay, so we've got 4 ln of 3 minus 3 ln of 4. Okay, so remember your properties of logarithms. Anything in front of your log you can put up as a power. Any coefficients? So we have ln of 3 to the 4 minus ln of 4 to the 3. Okay, that subtraction we can turn into division when we combine these as one logarithm. So ln of 3 to the 4 over 4 to the 3. Okay, so now we've got everything into one log. We don't have any coefficients in front. We've combined it. We've combined subtraction using division, so it's totally one logarithm. So let's replace that. Let's substitute this back in here. So it's a power of e, right? So we have e to this power. So e to the ln of and then remember that idea that if we have e to the natural log of something, this part is actually going to cancel. And we're left with 3 to the 4 over 4 to the 3. So solving exponential equations. This is when we have an unknown as a power, as an exponent. So our variable is in the exponent, and we can't access it that way. We have to get it down from the exponent in order to solve for it. So, and also, we've looked at these before, but we've looked at them when we can get the same base on both sides. So in this case, it's very difficult for us to use our head and think, okay, 1.04 to what power is going to give me 3? It's very difficult to get a base of 1.04 on the other side. So we can use logarithms, and we can use our calculator to help us here. So in order to get that power of t, that unknown exponent, down out of the power, we can take the log of both sides. And we can only do that, say for example we had a +1 in front. We need to simplify everything to one value first, I guess. So that plus 1 we'd have to subtract to the other side first before we took the log of both sides. So we can't take the log of both sides until it's been compacted into kind of one unit on each side. Okay, so we're going to take the log of both sides. Then we'll bring down our exponent of t. Remember, with our properties of logarithms, we can bring this exponent now down in front. So we do that in that next step. So we've got t times the log of 1.04 is equal to the log of 3. Log of 1.04, that's just a number. So it's saying it's a base of 10, right? So 10 to what power gives me 1.04. We know it's a very, very small number, but yeah, it's just a number. So this we can then divide to the other side. This is wrong. So we're going to have t is equal to log of 3 divided by log of 1.04. Because this, to move that part to the other side, this part, to solve for t, we're going to have to divide it to the other side. And notice that this is not the same as subtraction. We're actually going to have to plug this into our calculator. Remember, subtraction of two logarithmic values, so something like this, turns into division with just one log. So this here is not related to that. It has nothing to do with that property. What we're actually going to have to do is we're going to have to plug this into our calculator. So we'll have log of 3. So to get log, we'll do control. Oops. And it gives you the option for your base. So you can use 10 for your base. And then of 3. So log base 10 of 3, notice, is just a number. It's a small number because it'll be a root of 10, right? Almost a square root, but not quite. So, so 10 to the power of 0.477 is going to be equal to 3. Okay, and we want to divide that by log base 10. Of 1.04. Okay, and we get 28.011. Okay, so about 28. And those squiggly equal signs mean about, right? So 1.04, if we were to do that on our calculator, 1.04 to the power of 28 should give us very close to 3. Yeah, 2.99. Okay, so that's a way that you can check your answer. You can plug that value back into the exponential equation. Okay, so our calculator is a super useful tool when we're solving these logarithms, and it's not easy for us to just do it in our head. So for example, for this one here, if we were to try and do this in our head, we'd be thinking, okay, 6 to what power gives me 25? Well, we know 6 to the power of 1 gives us 6, and we know 6 squared gives us 36. So we know x is going to be somewhere between 1 and 2, right? Probably closer to 2 than 1. Closer to 25 is closer to 36 than it is to 6. So x is somewhere between 1 and 2, but you know, to be able to pinpoint exactly what it is pretty difficult for us to do in our heads. So we can use our calculators very easily. We can say log base 6 of 25 is equal to about 1.80. And it's a good idea to still think about this in your head. So in this one, if this is equal to x, we're thinking, okay, 20 to what power is going to give me 5? Well, we know it's going to be some very small number, right? It's 20 to the power of 0. is going to give us 1. So we want it to be bigger than 1, but 20 to the power of 1 gives us 20. And we know 5 is somewhere between 1 and 20. So x is going to be somewhere between 0 and 1. Okay, so this is just something you should be thinking about in your head, not work that you'll need to show or anything, but it's nice to at least think about that value. So we're expecting this to be somewhere between 0 and 1. So it's 0.537. Okay, these next ones require a little bit of work. So 12, it's not easy to write 12 with a base of 3. It's not something we can just kind of do in our head generally. So we can rewrite this in logarithmic form, which is going to be log base 3 of 12 is equal to x plus 2. And so we can do that logarithm on our calculator then. So log base 3 of 12 is equal to about 2.26. This is equal to x plus 2, so then we can minus 2 from both sides, and we get about 0.26 is equal to x. Okay. Yeah, let's do one more here. We'll do number 4, and I'll leave number 5 for you to do. So here are our solutions. Number 4, again, 10. It's very difficult for us to write the number 10 with a base of 15, like we did last unit. So we can use logarithms. We can use our calculator to help us here. So we can rewrite this in logarithmic form. So we've got log base 15 of 10 is equal to our exponent, 3x minus 2. Okay, and so we can do log base 15 of 10, and that is 0.850. Okay, so we can add 2 to that then, and we can divide it by 3, and we'll get 0.95 about. So like I said, I'll leave that last one for you to do, and you can check your answer here. So now we've got exponents on both sides. To get those exponents down, we can take the log of both sides. So it doesn't actually matter what your base is for your log. So you can use log base 10, you can use natural log, you could use log base 2. It really honestly doesn't matter as long as you use the same base on both sides. Okay, so I've just used log base 10. We can bring our exponents down as coefficients in front of our logs. So we'll have x times the log base 10 of 4 is equal to x minus 1. It's really important to keep this in brackets. Log base 10 of 5. So now we can actually distribute this log of 5 to both of these values. Log of 5 is just a number. So we're saying 10 to what power gives me 5, basically, when we're doing this. And just to show you, it's just a number. Log base 10 of 5 is 0.699. Okay, so we've got log, x times log of 4 is equal to x log of 5 minus log of 5. And if you're uncomfortable with this in here, you can just replace it with what you got for your simplified answer here, the decimal. Okay, so if you don't like working with these log of 5s, you can totally just say, okay, this is x times 0.699 minus 0.699. And you can do log of 4 and simplify that too. Log base 10 of 4. Okay. Okay, so that is x times 0.602. Okay, so now we're just working with decimals, and we're solving for x. So we're definitely going to have to get all our x's on one side. So let's see, I like to work with positive numbers, so okay, so we have 0.699 minus 0.602. That gives us 0.097x. And we can add this 0.699 to the other side. So we have, and then we can divide both sides by 0.097. So about 7.21. Let's do number 2, and then I'll leave number 3 for you to try, just to show you that we can use a log of any base. Let's use a different one here. So number 2, let's take the natural log of both sides. Okay, and then we can bring down our exponents as coefficients. I'm not going to convert these to decimals until the very end this time, so just so you can see a difference there. So we've got 2x ln of 6. We're going to distribute this ln of 8 to both of these terms, so we can separate our x. 3 times ln of 8 times x minus ln of 8. We can subtract this to the other side. Okay, so we've got 2 ln of 6 x minus 3 ln of 8 x, and that's equal to ln of 8. This is actually negative ln of 8. We can factor x out from both sides. Okay, and then we can divide this quantity to the other side. Okay, and then I've already plugged that into the calculator here. So when we do that, we should get x is about 0.783. Okay, and by the way, to get ln, you do Control E on your calculator. Okay, that's where that comes from. Maybe we'll do the first one together, but the rest you can just take a peek at the answers. In this first one, it's hard for us to write 10 with a base of 2 in our heads, so we'll take the log of both sides, or we can just simply write it in logarithmic form, honestly. So we'll have log base 2 of 10 is equal to x, and we can plug that into our calculator, or we can take the log of both sides, so log of 2 to the x equals 10. And then we can bring down our exponent. So we got, log of both sides. So, okay, so we bring down our exponent. You should recognize log base 10 of 10 is 1. But even if you don't, it's okay, because we'll divide both sides by log of 2, and then we can just let the calculator do the work for us. So option number 1, you can write it simply in logarithmic form. Option number 2, you can take the log of both sides, and it doesn't matter what your base is. So option 1, if we put that into the calculator, so we're dealing with log base 2 of 10, and that gives us 3.32, or we can do log base 10 of 10, which again we should recognize is 1, but even if you don't, we can do that divided by log base 10 of 2. And we should get the same answer, 3.32. So either way, you can write it in logarithmic form, or like the previous ones we did, you can take the log of both sides. Okay, and here are all the solutions to those, so feel free to continue to play around with those ideas. Okay, here we're going to take the log of both sides again, or we can simply write it in logarithmic form. So either way, in fact, I'm going to take the natural log of both sides, because you can take the log of any base. So when we take the natural log of both sides, we can bring down our exponent as a coefficient. Okay, so we took the natural log of both sides, and we just brought down our coefficient, our exponent as a coefficient in front of our log. Now we can divide both sides. And we get x plus 3 equals ln of 7 over ln of 4. And to solve for x, we'll have to subtract 3. Okay, and that's what we'll put into our calculator. All right, and then I've actually plugged this into our calculator here. And that gives us about negative 1.60. So we're going to have to first get log on both sides, and just a single log. So we can put our exponents up here. So we've got log of x equals log of a to the power of 8 minus log of b to the power of 5. And that subtraction we can combine into a single log with division. Okay, so now we've got the log with the same base, a base of 10 on both sides. So now we can cancel that log base 10, or what we're really doing is we're taking 10 to those powers on both sides, and that cancels. So we're left with x is equal to a to the 8 over b to the 5. Okay, last one. Okay, again, we're going to want a single logarithm on both sides. So this subtraction, we don't have any coefficients, so right away we can turn this subtraction right into division. So log base 5 of 7x over x plus 1. We want a log base 5 on this side too. So in our head, we've got log base 5 of what? Some value is equal to 1. Well, if we write that in exponential form, we've got our base 5 to a power of 1 is equal to x. Well, that's just 5, so 5 equals x. And we should know that log base 5 of 5 is equal to 1. So we're going to replace this 1 with log base 5 of 5. So we've got a log base 5 on both sides, which we can now cancel. So we get 7x over x plus 1 equals 5. And then we're just solving this rational equation. So 7x equals 5x plus 5, we can minus 5x, and we get 2x equals 5, and x equals 5 over 2. Okay, thanks a lot.